then in this case, there's no force pointing to the x direction. So your x component of the force is 0. The force is going positive in the y direction. So in this case, the y component of the force is exactly how big of the force you apply. Okay? And how will that affect your acceleration? Because the x component of the force is 0, 0 must equal 0. The mass of the particle is not 0. So you get that if you have no force in the x direction, you should have no acceleration in the x direction. Now, because you have a force in the y direction, the y component of your force is F. To get acceleration, we know that right now Fy is F. This thing is m times ay. I just want ay. So you divide both sides with mass, and the mass on the right hand side cancels. So after the algebra, you get that the y acceleration should be F divided by m, the force you apply divided by the mass of the particle. Let's get it in a better form, as I want to describe ay. So if you look at this and run a tendency check, you see if the force you apply if you apply a bigger force, the result is more significant. You have a bigger acceleration, so it makes sense. And if the mass is bigger, you have a smaller acceleration. If you try to push a heavy object with the same amount of force, it will have smaller effect compared to lighter object. So indeed, the tendency makes sense. The bigger the mass is, the smaller the acceleration if you apply the same amount of force. Any question? Now, if on our case, the force I'm applying on this particle is going in positive x. This is a particle. This is xy plane, so this is exactly what's happening. There's a thing over here, and I'm putting it in this way. In this case, the acceleration of the ball will only have x component, because in this case, the x component of the force will be the force you apply, and the y component of the force will be 0. And so, you know that the x acceleration will be force divided by the mass, and the y acceleration will be 0. Okay? So, this is how physics works. You figure out the force that is applying on the particle, and then you get the acceleration. But how do you get the motion out from the acceleration? I hope you all have done the previous homework. If you have acceleration, let's say in the x direction, then your x velocity will be changing. This is only if the x acceleration is a constant. If it is not a constant, the change of x velocity will be different. And the way it changes is that it will increase the x velocity. But it doesn't tell you how fast the object is moving initially. And there's no way physics law can tell you that, because the velocity is frame dependent. everyone will think that the velocity is different if you are in different frame. So, to get the initial velocity, you need to specify which frame you're in. And the problem you're doing should have a way to tell you how big is the initial velocity, because you cannot get that from f equals ma. Okay? What you can get from f equals ma is that after some time, t, because acceleration is the slope of this line, the x velocity will be changed by the slope times the amount of time passed. And then if you want to get how much displacement the object has moved, you learn that the area under this curve will be the displacement. So you know that after some time t, under this acceleration and the initial velocity given, the displacement will be the area of here, right? This is a square and it's a triangle. The square has t here. This is b naught n. So base times height gives you the area of the rectangle. And for a triangle, you have the base, which is also t. The height here is the change of velocity, which is at. So you have 1/2 base times height. T times t is t squared. So you have 1/2 at squared. So that's how you know the displacement in the x direction under a constant ax and a given initial x velocity. If you want to figure out the position, again, f equals ma doesn't tell you how. It doesn't tell you where the particle is going to start moving, because that's not about physics. You know where the particle starts moving depending on your frame you're working on. If the particle starts at this point in your frame, then you start at that point in the frame. You need to get it from the problem statement. The initial position and initial velocity are called initial conditions. They depends on the frame. That depends on how you set out your problems, and you cannot get them from f equals ma. What you get is acceleration. Okay? If I am dropping a thing up here, if I release something from rest, and it just dropped down, then in the beginning, in my frame, this thing is not moving, so the initial velocity is 0. I know it not because of f equals ma. I know it because I told you I released the thing from rest. Okay? Now, how about the initial position? Then you need to say that, okay, I want to set my frame such that the thing is at a height h above the ground, and I set the origin on the ground. Then you know the initial position of the thing is, what is the initial x position? If I set a frame like this, the ball initially is at here on the y-axis. Good. How about the initial y position? Good. So this is how you know the initial position. It depends on your frame, and the final answer will not depend on which frame you choose. Okay, so f equals ma gives you acceleration, and by computing, so acceleration allows you to draw out a vt graph, and from a vt graph you can get the x displacement, and you can move it to the other side. In this equation, you see there's no t1, t2, there's only t. So you know that I said t1 to be 0 and t2 is just t. So in this equation, t1 is 0, which is the initial time. Delta x is the current position minus the initial position. So if you move it to the other side of the equation, you get a cross sign. And this is how you get the position of an object in your frame if it has a constant acceleration. So the general way to apply Newton's second law, is you figure out the force, and then you get the acceleration. Then the acceleration will only tell you the slope of your VT graph. It will not tell you where you should start drawing. You know where to set the intersection by looking at your frame and the initial velocity of the ball in the frame. And same with initial position. Then you can get how the position of the thing will change with time. This is x of t, x as a function of t. This is not multiplied by t. If I want to multiply by t, I will not use the parentheses, I will just place them together. If you look at this equation, you see the velocity will help you move the position, because when t becomes bigger, this turns becomes bigger, and that changes your position. The way acceleration affects your motion is by t squared. When t goes bigger, it also makes a becomes bigger by its t squared. And you can check the dimension. Position is like, this is like 3 meters to the top, so position should have a dimension of length. X position in the initial point is also a length. Velocity is length divided by time, so that's why you need to multiply by your time, so that the dimension agree with all the arbitrary. Acceleration is length divided by t squared, so that's why you need the t squared over here to cancel the t squared in the denominator. So everything in this equation is length, so it makes sense. Okay? I still need to remind you that this only works for constant acceleration. If acceleration is not a constant, you can still compute the area down here to get the x displacement, but that area will be, you need calculus to compute that kind of area in general, and I'm not going to ask you to do that, so don't worry. You need to know how to compute this area, and only this type of area, a triangle and a square. Okay?